right, so this was the question that y'all asked me to do as a video, so here it is. This was our original circuit, where we have the three same capacitors, all have, I changed it to 1 farad instead of microfarad just for simplicity. And so I have this one and this one in series, and these two in parallel with this one. And so I went ahead and simplified this down here, where I have the two that were in series simplified to this half a farad, and the one that it was in parallel with is still, it's 1 farad. And then I went ahead and simplified it down even more, and so we have an equivalent capacitance of 3/2 farads. So just remember, kind of backing this up, when I step this back just a little bit, I have a current coming into here, we'll call that I1, and then a current going this way, that's I2. So just like our resistors, then, I can think in terms of what's the same and what's different. So whatever is happening in this circuit and this circuit is going to have the same voltage. So the voltage is the same. So if I come back here and I say, okay, so coming into this one, when I have my equivalent circuit, I have this 10 volts going in. So that means that I have 10 volts over here. And so for the quiz question, it was which one was going to have more voltage drop across it, the C1 or the C2, where this was C1 and this one over here is C2. So I have 10 volts coming across here and 10 volts coming across here, but this one comes back to here where I have now 2 capacitors sharing that same amount of total voltage drop. So I have 10 volts total between these two. So 2 ways to think about it is that I'm going to have 10 volts lost here. I'm going to have 10 volts total lost on this part of the circuit. So because they're equivalent, they're both 1 farad by equivalent, I mean, they're equal. That means I'm going to lose half my voltage here and the rest of it here. So I'd lose 5 volts there, 5 volts there, whereas I have 10 volts being lost across that one. So that is why that guy has the larger voltage drop.